let me just check that this is actually going through, and then we can get started. Yeah, we are good. Alright, nice. Okay. It has been over a month since we've last moved forward in OpenGL. I'm just going to get to the desktop. Alright, and we should be good. Well, hello everyone, and welcome back to OpenGL. We're going to be continuing on with the depth buffers today, and we are actually going to be fixing the error that came last time, and then we'll be creating classes to actually store the frame buffers. So if you remember, for some reason, I'm still not entirely sure what the reason is. I only have an idea of what the reason was. But whenever we ran this, there was a problem with the texture, and what I deduced the problem to be was that the bottom right corner, that texture coordinate was not being read properly. So you can see how that's just affecting pretty much everything here, because it's not reading that last texture coordinate properly. And I kind of had to test that through custom coding the fragment shader and just kind of doing a bunch of if-else statements. But for some reason, now this is the part where it gets really weird, is if we add memory, if we add a second vertex after it, so if we kind of pad the end, it will turn out properly. So the way we're going to kind of implement this is, in the mesh class, we're going to have a Boolean parameter in the load data function. Let me just get that. And we will call it bool pad, and this is going to be equal to false by default. And we're going to use default parameters so we don't have to change all calls to load data. And then in mesh.cpp, just add that parameter, bool pad, and then what we're going to do is, for the VBO, we are going to have an if statement here. So let me just find the code here. Alright, here we go. So underneath where we bind the VBO, we're going to have an integer size, which is going to be equal to the default size. So this dot vertices dot size. And then we're going to say if pad and size plus plus. So if we want to pad the vertices, we're going to increase the size, but I also have the and with size here, because if there are no vertices to pad, then we just don't want to pad it, then we don't want to pass any data in. And then when we say set data, we're going to pass in the integer size. We can call this an unsigned integer too. And it doesn't really matter what the data is in that last vertex, because, or in that the memory after the vertex list, because we're never going to be accessing it at all. The EBO only uses indices to access data that we want to read. So let's say we had data, let's say we had 5 indices, so in indices 0 to 4, or let's do our example here. So we have 4 vertices, so indices 0 to 3, and we pad it so it goes 0 to 4. We're never going to make a call, or we're never going to access the index or the vertex at index 4. That's just because it's just never in the index list. So now this should work when we go to plain.hpp and then say ret.loadData and pass in true for pad. Now if we run this should work. I hope it does. And come on. There we go. It's fucking working. and everything else still works. We're looking good. Nice. So I guess I can kind of analyze this now. So the depth, the way we programmed it was that if something is closer, it's going to be wider. So you see that as points in the plane get further, they get a little darker, and then as we also move away, everything gets progressively darker, like that, which is kind of neat. But you can still see that each distinct cube and lamp, because they're closer than the plane, or the large floor that we have. All right, nice. Okay, and then another thing that we can take a look at is actually we can, since we don't care about the colors here, so only when we're using the depth, the depth buffer, we only care about the depth value. And if we only wanted to display something based on that depth value, we don't really care about the color, so we don't have to spend time doing all these costly calculations in object.fs that considers the light values and all this stuff here. So we can just create a much simpler fragment shader, and I'm just gonna copy and paste a fragment shader into the assets folder, and I will rename it as depth.fs. And all we have to say is have the macros of version 330 core, out vec4 frag color, and then our main method void main, and all we can say is just frag color is equal to vec4 1.0. So we just set it to white because it doesn't really matter, and this will not affect the output at all because we're still just displaying, or wait, we haven't actually used a shader, but we can do that by going to main.cpp, and in our shader here, just change object.fs to depth.fs. Now when we run this, output should still be the same, even though we're using the different the different shader, which is nice. Okay, so now let's do something that we didn't do last time, and that's actually experiment with the color buffer. So let's, how do we want to do this? I guess let's start in main.cpp. And essentially all we have to do is just switch around the formats. So in main.cpp, currently we use a texture to store the depth value, so it's just has a depth component and a float. And then we use an RBO, a render buffer, to store the unformatted colors. But now what we can do is actually switch those around. So we're using the texture to store the colors of the objects, and this, we've seen this texture generation, so just replace the gltext image 2D call with gltext image 2D. So underneath where we bind the, here, let me actually zoom in. I actually did not zoom in at all. Oops. Okay, that's, oh yeah, I forgot to do that actually. So let me just go back to mesh so you guys can see what I did there. Yeah, we just added this padding parameter right there, and then we had this if statement to determine the new size, and we pass in that size to set data. Just leave that there for a second, and then then after this we also just created the new fragment shader, because we don't need to access the colors, or we don't need to calculate the colors for the depth value. So we can just use this shader just to give it a white color. Okay, that's good enough. So now we're in main.cpp, and after we bind the texture, we just have to replace this text image 2D, so the allocation method, by just calling GL text image 2D, so the same method call. We're going to pass in the same target, GL texture 2D, 0 for the level. Now the internal format is now GL RGB because we're storing a color. Or we could, let's do RGBA actually, because remember we are returning a 4D vector, so we do need to have that last component in there. Then buffer width, buffer height, 0 for the border, same format GL RGBA. Type will be GL unsigned byte, and then null for the pixels. And once again, it's null because we only want to allocate the memory since we are going to be writing to it. Then we can to actually attach the texture to the frame buffer, we have to replace the depth attachment. So in GL frame buffer texture 2D, we have GL frame buffer for the target. Then the attachment type will actually be GL color attachment 0. So this is what we saw with the RBO. So we're essentially just moving the color attachment to the RBO. Now for the RBO, just put that right there. We're going to switch around the storage format and then also the attachment parameters. So for the call to GL render buffer storage will be GL render buffer storage. We're going to pass in as the target GL render buffer. The format will now be it will be GL depth 24 stencil 8. Then the width will be buffer width and the same height, buffer height. So GL depth 24 stencil 8 is essentially combining the depth bit and the stencil bit into a single byte. So the depth will take up 24 bits, which is 3 bytes, or wait, 3 bytes, and then the stencil takes up 8 bits, which is 1 byte. So that combined they take up the memory of an integer. And then now we're going to say for the attachment, we're going to make the call to GL frame buffer render buffer. Target is GL frame buffer. The attachment type will be GL depth underscore stencil attachment because we are attaching both. This render buffer will take in both. Then the target will be hold on. GL render buffer again for the target, and then we're going to have RBO as the render buffer itself. Okay, so I believe we should be all good. Let me just make sure I got all the necessary changes here. Alright, looks good. Okay, now what we have to do is change the calculation of the color. So we are outputting an RGBA, so for a 4D vector into we're taking in a 4D vector from the texture. So we're going to say in buffer.fs, you can just comment all of this code out here. And now that since we're using a color map, we can just take the color directly from the texture. So frag color is equal to texture buffer text and just pass in the coordinate. And this will return an RGBA, a 4D vector, which we want to return. And then since we want to reuse the colors, we just have to recompile or set the shader to compile the object.fs again. Now let's run this and we should see how the color buffer works. So this is what we would see if if we just use the default frame buffer to render stuff. And essentially this is all the default frame buffer does. It takes it automatically takes the color buffer, so all these color values that are calculated in the shader, and it will then display them to the viewport, which we set with GL viewport. So it's kind of like just putting on a quad, but we are kind of adding a step in the process just to demonstrate how the frame buffer works. But yeah, so that's pretty cool. Now that we have looked into the color buffer, let's go ahead and actually try and organize this code into classes, so that we can then use this we can make more use of this in when we're doing shadows, because since each shadow will produce, or each light will produce a different shadow, we're going to have frame buffers for each light, and as a result, we will just have to we can just pass in, or have each light have a frame buffer object associated with it. Okay. Let's start by renaming one of our files here. Okay, we are going to rename the GL memory class to just vertex memory, because we're going to be creating a class that looks kind of like this. So we're going to want to, we want to, because GL memory is very general, that's just GL memory, so we want to name this as vertex memory to not have any confusion. And then make sure to redefine your macros in that class, in that file. And then we're going to do a Control F to actually replace all of the includes. So entire solution, we're going to replace glmemory.hpp with vertexmemory.hpp, because we want to include the right file. Alright, foreground is replaced. Text good. Mesh good. Cube map good. Box good. Alright, let's run this just to make sure everything works. Everything still works. Alright, looking good, looking good. Sorry, give me a second. Alright, we're good in vertexmemory.hpp. And then now we're going to create a new file called framememory.hpp. So it'll be in the graphics folder again. Start with our macros, if not defined. Frame memory. Define frame mem. God, that's a really weird thing to type because there's two MEs. It's FRAMEMEM. So meme M. That's nice. And then end if. For the includes, we're going to include glad and glfw/glfw3.h. And then also we're going to include texture.h. Alright, so let's start with the render buffer class, just because we're going to need it for the frame buffer. So we'll have class, render buffer object, and the basic things we need here. In the public sector, we're going to have a GLUint value. That's just pretty much what everything is represented within OpenGL, and that's what we have it as represented within the main file. And then what we're going to need to do here is we're going to need a generation method, void generate. We're going to need a bind method, void bind, and then also allocate, so we can actually set up memory to store stuff in. So void allocate GLEnum format, GLUint width, and GLUint height as the parameters. Okay, for generate, these are all one-line methods, and once again we're just abstracting the code here, so it's easier to read. So glgen render buffers, 1 and then a reference to val. Then for the bind, it's going to be glbind render buffer. The target will be gl_ render buffer, and then val for the render buffer value. And then for allocate, I'm just taking the code essentially from the main file. We're going to have gl render buffer storage is the method. Pass in gl render buffer as the target. The format will be format, then pass in width and height. Just like that. Okay, now class Framebuffer object. Let me actually test something out here. Oh no. It's getting, Visual Studio is going colorblind again. Okay, I'm gonna test GL delete. Ooh, we can actually delete these render buffers. Oh, we didn't even do that for the frame buffers. What's up, Mert? So we'll just have an extra method here, void clean up, and we'll just call GL delete render buffers 1 and then a reference to val. Oops. Okay, now for the frame buffer object, we're going to be incorporating this render buffer object class, not as a member, but as a parameter into a method, actually. So in the frame buffer public, we're going to have a value, just following suit, and then since this is a frame, we're going to have a width and a height, GLUint width, and GLUint height. And then we're also going to want to have a bit combination here. And specifically, we're going to be looking for bits that look like this: GL depth buffer bit, GL color buffer bit, and GL stencil buffer bit. So whenever we want to clean the frame buffer, we can just call frame fbo.clean, and we'll have a clean method here. And that will clear the bits that are associated with this frame buffer. So it has to be GL bit field, bit combo. So a bit field is another name for just a combination of bits, of switches rather, that are used to store states. Okay, we're going to have a default constructor, frame buffer object, no parameters, and then we will initialize all the values to 0. So val goes to 0, width goes to 0, height goes to 0, and bit combo goes to 0. Then the frame buffer object, we will pass in a GLUint width, height, and a GL bit field combo, or GL bit field bit combo, and then just initialize each value as its respective parameter. But value just will still go to 0. And bit combo goes to bit combo. Awesome. Alright, now we're going to have a couple of quick methods here. We're going to void generate glgen framebuffers 1 and then a reference to val. Then we're going to have void bind. This will bind the frame buffer, gl bind frame buffer. Target will be gl frame buffer and the value frame buffer, and the value will be val from the class. Then we're going to have the set viewport, void set viewport, no parameters, and this will simply set gl viewport or call gl viewport x 0, y 0, and then the width and height are the width and height values within this frame buffer class. So we're using these parameters here just as a standard whenever we want to call gl viewport. And then void clear, this will just call gl clear and we will pass in the bit combo. So if we pass in to the bit into the constructor gl depth buffer bitwise or with gl color buffer bitwise or with gl stencil buffer bit, this will combine all three states, and when we call gl clear, it will clear all three states. And then one other thing we want to do is have a void activate method. This will we'll call this at the beginning of each loop. This will bind, set the viewport, and then also clear. So this is just the one method that we can call if we want to just activate the current frame buffer to actually render to. Now for attachment methods, we're going to have two methods. One to attach the render buffer, which we have right here, and then another one to attach the a texture. Let me actually try something out here. I feel like we don't even need a render buffer object class, to be honest. Yeah, I think we don't need it, because we can just have a list of integers in the frame buffer object class to just store a list of the render buffer objects, and then cleanup will just call gl delete render buffers, and then we can just, because we only explicitly access the render buffer in its generation. So if we just condense this into a single method in the frame buffer class, that can reduce a lot of the code here. Food for thought, but let's try it. Okay, so we have to include vector here because we're going to include, or we're going to have a list. Then in the frame buffer class, we're going to have a standard vector of gl uints. And then we will have RBOs. It's not RBs, it is, we're not going out to get the meats at Arby's. This is render buffer objects. Okay, so now we're gonna have our method void attach RBO. We will pass in a gl enum attach type, and then we're going to pass in a format for what the value or the render buffer will store. So gl enum format. Okay. So now I need to figure out how I want to do this. I'm just going to copy and paste this into here so I can go from it. Okay, so we have to actually set up or allocate memory for an integer value. So we're going to say unsigned int idx is equal to rbos.size. So this will get the index of the RBO of the new render buffer when we add it. Then we say rbos.pushback. We're just going to have a 0, or let's do -1 actually. Or wait, this is unsigned integers. So let's just do 0. Now we can access this value using rbos at idx. So we'll generate. So generate GL gen render buffers 1, and then a reference to rbos at idx. So the index was the previous size, and then when we add 1 to the size, that index becomes the last element, which is the new render buffer. Then we will bind. This is so GL bind render buffer. GL underscore render buffer is the target, and the value will be rbos at idx. Or, let's just generate the RBO up top here. So GL uint RBO, and then when we generate, we actually just pass in a reference to RBO, then bind RBO, and we'll add it at the end. Then to set the storage, we will say GL render buffer storage, GL render buffer as a target. The internal format will be format. Then the width and the height are from the Framebuffer class. And then to attach it, we're going to say GL Framebuffer render buffer, GL Framebuffer as the target. The attachment will be attach type, and then the render buffer target will be GL render buffer, and then the actual value will be RBO. That should be good there. Let me just switch the order of these parameters since we use the format first. And then now at the end, we want to add the render buffer object to the list. So rbos.pushback RBO. Okay, I believe that should be good. I want to do something similar with the texture. We'll have two. Shit. GL delete textures. All right, let's do something similar for the textures. So we'll have two methods here to attach textures. We'll have one to attach a blank one and actually allocate the memory, and then we'll have one to attach a texture that has already been allocated. But first we have to add a few methods to the texture class here. So in texture.h, we're going to add a void allocate method, and we will pass in GLEnum format, GLUint width, GLUint height, and then GLEnum type. And then we also want to have a static method here to set the parameters, because we don't want to have these for calls to parameters in this main method. So we just want to set them in a static method, since it's not specific to this texture. So static void set params. We'll have form parameters, GLEnum text min filter. Default will be GL nearest. GLEnum text mag filter. Default will be GL nearest. GLEnum wrap s will be default is GL repeat, and then GLEnum wrap t default is GL repeat. Okay. And now we can copy these definitions, put them in texture.cpp. Make sure to add your texture tags, the class tags. And then for the static method, you want to remove this static keyword, and then also remove the default parameters. Alright, let's start with allocate. Alright, allocate, all it does is just calls GL text image 2D. Pass in the target GL texture 2D. The level is 0. Format is format. Then width and height are width and height. Border is 0. Format, again, pass in the type this time. And then the pixels are null because we are simply allocating memory instead of assigning values. And then for the set params, you can copy the for calls here to GL text parameter I, and then just replace each parameter. So GL texture min filter, that GL nearest there gets replaced with text min filter, and so on. Like so. Give me one more second. And I guess we can add a cleanup method to the texture since we don't have it. Just void cleanup. And then in texture.cpp, this would just simply be GL delete textures 1, and then a reference to text or a reference to ID. Or is it ID? It should be. Oh, and then we just make sure to add your texture class tags too. Okay, that's it for the texture class. Now back to frame memory. So we'll have, I don't know if I want to have, oh, you know what we can do? We can have a similar list of std vector of textures, and then we'll have the list of textures that this class allocated. So blank textures. or just textures actually, because we only want to delete the textures at the end that this class allocates, because if we need access to a texture that we write to in a render buffer after deleting the, or that we write to in a frame buffer after deleting the frame buffer, we can set that up outside of the frame buffer. So we're gonna have two methods here: void attach blank, or allocate, or let's say allocate, or what do I want to call this, because we want to allocate and attach texture, so we'll call it allocate and attach texture, I guess. Pretty intuitive. We will have, what do we want? GL enum attach type, and then texture allocate requires a format and a type. So then we just need to pass in a GL enum format and a GL enum type. Okay. So let me, this is going to be, let me copy and paste once again the code we used to generate the texture. Right here. Okay, so we will create this texture text. We'll pass in the name. I don't fucking know. I don't think the name really matters here, but just in case, we should create unique names. So we need to construct it using the numbers. So standard string name is equal to text, and then plus textures dot size. Then texture buffer text, or just texture text, and we'll pass in the name as the name. Then we want to say text.bind, then text.allocate, and the format will be the format that we passed in. The width will be the width of the frame buffer, then the height will be the height of the frame buffer, then the type will be the type that we passed in. And then texture, so now we're going to be calling the static method. So capital T texture, calling the class, colon, set params, and then we want to attach. So we need to bind this frame buffer, so just call bind, and then GL frame buffer texture 2D, target is GL frame buffer, the attachment is the attach type parameter, text target will be GL texture 2D, then the texture integer will be text.id, and then level will be 0. Awesome. Damn, it's getting quiet without this fucking music. It's been a while since we've listened to what you know, I guess we'll just leave it blank for now, or quiet for now. Okay, so that's allocating a new texture, and then we can also have, and then we need to add the texture to the list. So textures dot pushback, and pass in text as the value, and then we want to have another method, void attach texture, pass in GL enum attach type, and texture text. And this will simply just attach an existing texture. Sorry, my other computer keeps going to sleep. Let's come on. This is just a simple call. GL Framebuffer, texture 2D. GL Framebuffer is the target. Attachment will be attach type. Text target is GL texture 2D. Texture will be text.id and level will be 0. Okay, and then for cleanup, we're first going to delete the RBOs, then delete the textures, delete the generated textures. So we're only going to delete the textures that we called allocate on, and then we'll delete the FBO. So for the RBOs, we can actually just say GL delete render buffers. The number of values will be RBOs.size, and then the render buffers will be, or the pointer will be a reference to RBOs at 0. The reason why this works is because we're getting a reference to the 0th element, and because the vector stores elements in an array, it will just access the render buffers sequentially. And for the textures, it's not as simple because it's in a class. We have to actually iterate through each one. So for texture t in textures t.cleanup, and then for the FBO, it's going to be GL delete frame buffers 1 and then a reference to val. Nice. Okay, let's try putting this into our main class now. So in main.cpp, we just have to add the include. So hashtag include graphics / frame memory.hpp. And this is going to get a little messy. Or actually it won't. That's a lie. So everything underneath, or everything consisting of the FBO or the RBO, we can actually just delete. I'm going to leave the check. I'm just going to leave the error checking there for now. But everything from buffer width, where we initialize those, to attaching the render buffer, just delete that. And we're going to replace it with, or actually leave the buffer width and buffer height declarations there, because we'll use those. So underneath where we set the width and height, we're going to set up a frame buffer object, FBO, pass in a buffer width, buffer height, and then the bit combo will be GL depth buffer bit, bitwise ORed with GL color buffer bit. So once again, this just means that we will be clearing the depth and color buffer bits when we call GL clear. And then FBO.generate. Then what we can say is, we can use the method FBO.allocate and attach texture. The attach type will be, we'll just do the color first. So attach type will be GL color attachment 0. The format will be GL RGBA, and then the type will be GL unsigned byte. And then we actually want to call FBO.bind first. Let me just go back here. Okay, nice. And then we can also do the same, something similar for the RBO. So FBO dot attach RBO. We should actually, let's implement the same kind of thing for the RBO, where we have two separate methods. Just because I don't think there would be a separate. Do we actually want to? No. Because we don't have a class for RBOs, so it wouldn't make sense. So we're just going to disregard what I just said. FBO dot attach RBO. But let's name this actually to allocate and attach RBO, because that's a better name. So this method should become allocate and attach, because that's essentially what we're doing. And we'll pass in the format will be GL depth stencil attachment, and then the attach, the format. We should actually, I reverse those parameters, but I want to keep it attach type first. So the attach type will be GL depth stencil attachment, and then the format will be GL depth 24 underscore stencil 8. So this is exactly what we had last time. And this should be good, except we have something here. Oh shit. Okay, because we pass in the buffer texture to the plane as its texture. So let's actually allocate the texture separately, just to do that. So that's just a simple fix here. Texture buffer text. So we'll allocate the texture actually in main.cpp, and the name will be buffer text. Then buffer text.bind, then buffer text.allocate, pass in glRGBA, buffer width, buffer height, and the type will be GL unsigned byte. Then call the static method texture : set params. And then now what we have to do is, instead of calling fbo.allocate and attach texture, we're going to say fbo.attach texture, pass in the attach type is GL color attachment 0, and the text will be just buffer text. And then now everything else should be in order, except in the main method we have to actually call the the Framebuffers activation method. So replace the code where we bind the frame buffer, just the GL calls, in the main method with fbo.activate. Because remember, that binds the frame buffer, clears the bits, and then sets the viewport. So now let's try running this again. Ooh, spooky, and it works. Nice. Awesome. Okay. Yeah, that's... Alright, that's good. And then the one last thing that I wanted to do was actually have an instance of the FrameBuffer class for the default FrameBuffer in the scene class. So in scene.h, we're going to have a public member. Well, we have to include the class first. So include graphics/framememory.hpp. then we'll have a public member, frame buffer object, default FBO. So we will just have the default frame buffer, which GLFW automatically allocates and sets up for us in here. And then in scene.cpp, what we want to do is in the constructor of the scene class, what do we say here? Underneath where we set the window dimensions, the static variables, we're going to say default FBO is equal to frame buffer object, pass in the screen width, screen height, and then we're going to bitwise or GL color buffer bit, GL depth buffer bit, and GL stencil buffer bit. Because we're using all three of these bits. And we don't have to set the value for this FBO because the default frame buffer has a value of 0. And then the last thing we have to do in this class is in update. We just have to, we can replace the clear call here with default FBO dot clear. Then in main.cpp, what we can do is also go where we rebind the default frame buffer in the main method and call scene.defaultFBO.activate. Because this will bind the default frame buffer, set the viewport again, and then also clear the bits. And then the one other call that I wanted to change was when we say GLBind frame buffer 0 in the after we set up the external FBO, just call the same thing scene.defaultFBO.bind, and then at the end after the while loop we can just delete the frame buffer or our frame buffer. So FBO.cleanup. And then we should also take care of the textures, but let's just test this to make sure everything works. And then we'll take care of the textures and clean all those up too. And we're good. Nice. Okay. Okay, so to clean up all the textures, we have to go into model.cpp. We actually have to go into mesh.cpp, and where we say in the mesh.cleanup method we have to take both the, or let me see, do we have texture list? Okay, the textures are held in the mesh, so we have to go into the mesh.cpp, and then after we clean up the VAO, we're going to say for texture t in textures, we're going to say t.cleanup, and then that should clean up all the textures, and we should also, that should apply to the plane too. I believe it will. Yes, it will. Let's run this, and still good. Exit, and we're all good. Okay, that was relatively short, I think. Not too long. That actually took an hour. Holy shit, that took a lot longer than I thought. But yeah, so that's frame buffer classes, and now it's going to be very easy to actually implement this with our light classes. So if we, in our light.h file, we can just add a frame buffer in here, so that whenever we render the frame buffer, we can actually just take that, we can just take this frame buffer and render the whole scene from this light's point of view. So yeah, that is pretty much all I wanted to talk about today. Yeah, I don't know. I don't really got anything else to say. But now that we have this, once again, we can look into texture, into shadows more, which is what we've been waiting over a month for, which is fucking ridiculous. But I had to do the redos for the stuff, and then I also ran into that stupid error that I was only recently able to figure out. But enough excuses. We'll be doing it very soon, I promise that. But yeah, hope you guys enjoyed. Have a good rest of your night, and yeah, I'll see you then. Have a good one.